Hey folks, in this video we're going to look at a circuit, DC circuit, and we're going to do an FRQ for the preparation for the AP Physics C exam. So we have a free response question that says consider the following circuit. We've got, of course, our voltage source, we've got a bunch of different resistors, a couple points A up here and B down here. It asks, at what rate does the battery deliver energy to the circuit? Find this current through the 20 ohm resistor, the potential difference between points A and B, at which of these 2 points is the potential higher. Find the energy dissipated by the 100 ohm resistor, which is right here, in 10 seconds. And then given that it's a solid cylinder that's 4 centimeters long, composed of a material whose resistivity is 0.45 ohms, I think that should be per meter, or ohm times meters. Determine its radius. Okay, I'm going to flip over, we're going to kind of go back and forth a bit. The two parallel branches, the one containing the 40 ohm resistor and the other a total of 120 ohms. So let's just go back and check at those. The one with the 40 ohm and then the one with a total of 120. They're two in parallel. So what they're talking about is here's the 40 ohm, and then here's the total of 120. The reason for that is that, of course, these are in series, so they just add up, and you get 120 ohms for that. So we've got two in parallel, 40 and 120. For that one, that is equivalent to a 30 ohm resistance. And the way that we find that is 1 over that total resistance is equal to the sum of the inverses of the other circuits. So those parallel circuits are a little weird, but once you get it down, it's not too bad. So that 30 ohm resistance, which is this whole part on the right side, all three of these combined together in parallel. So now we've boiled that down to this is basically 30 ohms. And then we have 10, 10, 30, and 10. And all four of those are in series. So, as it says, the 30 ohm resistance is in series with three 10 ohm resistors, giving it a total overall equivalent circuit resistance of 10 plus 10 plus 30 plus 10, or 60 ohms. The current supplied to the battery, if we know the voltage, which we do, 120 volts, using Ohm's law, V equals IR, we can see that the current must be 2 amps, doing some quick algebra there. And it must supply energy at a rate of P equals IV. We know the current is 2 amps, we know the voltage, so using P equals IV, the power is 240 watts. Part B, since 3 times as much current will flow through the 40 ohm resistor as the branch containing the 120 ohm of resistance. Let's break that down real quick. Just because this is 120 ohms of resistance and this is 40. So this is 3 times as much resistance as this. And when the current comes in, it sees the two options. It says, okay, the current can go through here or the current can go through here. It's going to likely choose the one with less resistance, but the proportionality of current between these two is exactly the same as if this is 3 times less resistance than this one, you'll get 3 times more current through this branch than through this one. So that's the reason for that. All right, so 3 times as much will flow through the 40 ohm as the 120 ohm. So the current through the 20 and 100 ohm resistors must be 0.5 amps, because going through this, when the current, we know we've got 2 amps of total current, and when it comes here, again, we've got 2 amps going in, we've got to have 2 amps coming out over here. So of that 2 amps, we know 3 times as much goes here. So 3/4 goes here, 1/4 goes here. We get 1.5 amps of current, and then 0.5 through the 20 and 100 ohm resistor. So part B, find the current through the 20 ohm. It must be our 0.5 amps. All right. Where are we at? C. All right, so 2 parts here. We're asked to both find the potential difference between points A and B, and which of these 2 points is the potential higher. All right, so for the first one, VA minus VB, what we can do is we can say the current times the 20 ohms of resistance that you get here. So when we're going all the way around, the way that the potential difference is going to work, the potential difference is going to basically drop every time it goes over these resistors. So we know this is 10 ohms, 10 ohms, 30 ohms equivalent, although we have these parallel ones here, and then 10 ohms here. So by the time it goes through here, it's been through 20 ohms of resistance. So that voltage, we have IR, so 0.5 amps times 20 ohms, and that should be, I think that's what it's saying. 0.5. Oh, never mind. Nope, I was reading that wrong. This 0.5 amps is not the current through these 20 ohms, it's the current through this 20 ohms. So between A and B, you have a potential difference of voltage here and a voltage here. So we're just looking between these two, and the 0.5 amps that's flowing through this side of the circuit is going through the 20 ohm and through the 100 ohm. So to figure this out, we're going to take the IR, current times the resistance of the 20 ohm, plus the current times resistance of the 100 ohm. And when we figure out that voltage drop across those resistors, that's going to be the difference between those 2 points. So this 60 volts that we get from doing this math is the voltage difference or the voltage drop across those two resistors. Point A is at higher potential, current flows from high to low, right? So if you start with 120 volts, you've got this high potential, and then as it flows, you get lower and lower and lower until you get back to the battery or the voltage source. D, because energy is equal to power multiplied by time. So this is kind of back from our energy unit, looking at what power is. It's energy or work divided by time. So energy is power times time, and we know that power here is equal to I squared R. So we get 0.5 amps squared times 100 ohms times 10 seconds is 250 joules. My cat plays with a grocery bag. All right, last one. We're going to use, so for this one, it's asking us, given that this 100 ohm resistor, this one over here on the right side, is a solid cylinder, 4 centimeters long, material whose resistivity is 0.45 ohms times meters, determine its radius. So we know we have this equation that resistance equals rho L over A, and for this area we're just going to use pi r squared for the cross-sectional area of a cylinder. So we're going to put our things in. For rho, we're going to put in this 0.45 ohms times meters. The length we know is 0.4 meters. Pi times the resistance. This is the total resistance. And keep in mind that it's important to differentiate between resistance and resistivity. Resistivity is that rho value that's ohms times meters. Resistance is, of course, just our 100 ohms. So this big R is resistance. That's our 100 ohms. The rho is our resistivity, 0.45 ohms times meters. And so when we put in our pi and our resistance and all that stuff, we need to square root it to solve for the radius, because radius is squared in our area formula. Once we do all that math, we get 7.6 millimeter radius for that cylinder resistor. Awesome. All right, so that is a little bit of DC circuits for you. Hopefully it was helpful, and we'll see you around.